Welcome to this session. We are going to discuss about project control through networks in this session. During the session we will touch upon several subjects and then about 8 of them are there. I think one, we begin with the work breakdown structures, then we try to understand Gantt charts, and we also understand networks and application of these networks to the projects and networks on AOA basis, and then network construction, critical path method, slacks and floats. So, these are the 8 items we are going to concentrate during this session. So, the session objective is to begin with the work breakdown structures. What does exactly work breakdown structure involves? We all know the project consists of several works to be done, and then all these works can be further subdivided into several tasks or activities, and then we group them and we organize them and we sequence them in such a manner so that we have a good understanding of the total work and also what the tasks and activities it consists of. Then progress of these activities on the time scale through Gantt charts. This is another thing which we will try to learn in this class. And network analysis, what do we do in the network analysis is to try to understand how these activities are sequenced, and then where are the events and what are the activities that are there in between events we will see. And we will also try to learn about the Fulkerson's rule for activity on the arch networks. Then what exactly it is we will see as we go through this session. And we try to understand how do we understand the critical path and how do we really look at it, and then what is the importance of that during this session. Then we will try to see what are the slacks and what are the floats that are there in these activities, and then we will be able to how do we make use of them during the project period. So, we now begin with the work breakdown structures. There are very many ways in which the work breakdown structures can be understood. We can start looking at them by looking at the agency who are involved in doing these different activities. And for example, there may be contractors involved, there may be designers involved, then we can look at them by the agency and the kind of activity that they are doing. Then the another way of looking at is the function oriented, and most of the departmental structures are like that. And in the project also there will be several departments like an accounts department, like a procurement department, like an engineering department, and this is a functional way of looking at these. Yet another way of understanding the work breakdown structures is based on the location, and some projects involve multi-locational activities. So, we can identify them by saying associating with them the location in which they are activities are carried out. Then there is another way of looking at them is to look at the cost oriented structures, and sometimes we identify some activities grouped together as cost centers, and then we understand the work breakdown structure using this kind of orientation. The last one we look at is a life cycle oriented one, which is associated with the project life cycles. And we discussed earlier in the project life cycle we have an identification, we have a planning and implementation, etc. Different stages of the project life cycle are there, based on that we use. So, here is on the board you can see a function based structure which is speaking about engineering, finance and accounts, and then the procurement division. You can see further how they are further subdivided into groups of tasks and activities under them. We also talked about the Gantt chart in the beginning. What is this Gantt chart? The Henry Gantt, who lived during 1861 to 1919, have started using these, developed these charts, and he is also known as the father of the project management. And then the charts involves preparing bar charts. And what are the bar charts in this? The top line shows the time scale and activities are written on the vertical line. So, you have a series of activities and the time plotted on this chart, and then you will see the duration of each of these activities, and then when they are starting and when they are ending. This is what a Gantt chart indicates. The starting date at time and finishing date and time of each activity is important to be identified, and this helps us understand the current status of the activities, either they are lagging behind or leading forward, and a typical bar chart of a small industrial chart is shown in the next picture here. You can see the weeks are identified there. The weeks are identified from 0, that is the start one, and first week, second week, third week, fourth week, fifth week, sixth, seventh week, and there is an ending week, and the last one is the 8th week. Then you have the different activities listed there, and you know which activity is beginning when, and then you can see that some 2 activities are starting in the 2nd week. Similarly, there is an overlap of activities in the 4th week, like that you have. So, it is sometimes you can see some of the activities can start only once activity is finished, and some others can be done simultaneously. The bar charts are useful in trying to understand what are the activities which need to be finished before we can start another one. Now, we will try to look at and then understand the networks. I mean, before we get into understanding the networks, we must be a little familiar with the terminology that is used, and we have several terms. We will try to look at them one by one. One is to speak about activity. What is, how an activity is defined? There are specific tasks or group of them which needs to be completed and as together, and then that all forms as one activity. And then there are events, and how do we define these events? An event is some kind of a milestone by which it indicates that you have finished that task and activity. And then you have critical activities. What are these critical activities? Critical activities are something which you have to understand that you have to finish them either before the start of other activities or the end of the other activities, because there is a critical path which we will discover as we do this network analysis, by which we will be able to understand what are all the activities and then how they are sequenced, which has to begin when and which has to finish when. That is how we will develop an understanding of the critical path that which we have. We also speak about a predecessor events and then a successor events. That means some of the events will occur before certain activities can begin, and some of them will occur only after these activities are done. So, this is how the predecessor and successor are decided, and sometimes you will see there can be some activities which can be concurrently done. That means they can be simultaneously we can work with them, and there are also dummy activities. And then how do we understand these dummy activities? These activities do not really what do we say, they are not dependent on the activities of the other things, but they show up some linkages between activities, and then they are associated with them, and then we will show them differently in the network charts. And then application to the projects. What is the good use of all this learning about networks and other things? We can put to 4 good uses these application to the projects. One is this networks analysis and this work based the structures will give us a understanding to go for a detailed project planning. And then it is also helpful in project control and how the leading and lagging events, sequencing and all that can be used for project control very well. The same things are useful for cost control also. How can we do that? I think we can avoid cost overruns, time overruns, indirect and opportunity costs. There may be sometimes by deploying resources, the men and material and equipment to finish some of these lagging events, we may be able to do some kind of a time and cost saving. So, there are these Fulkerson's rule of activities on arch networks, they are given. So, how was these network diagrams are depicted, and then these are the Fulkerson's rule really tell us about them, how events are represented, how activities are represented, and what kind of lines and what kind of things are used is what we can learn from the Fulkerson's rules for activities on the arch networks. So, we can now look at the network construction, and how do we actually do this network construction. We will try to understand and learn this through identifying various activities that are involved in a small exercise, like building a two-storied building, and we can list the series of events that are there. So, excavation of the land, foundation laying, beam and columns from the ground floor and walls around the ground floor, and plastering the ground floor walls, roofing, and then ground floor, beams and columns first floor, walls on the first floor, plastering the first floor walls, roofing on the first floor. Like that you can have a sequence of these events. Using our understanding so far, we can now understand, try to go for looking at what is this critical path method. I think the critical path is the longest path, but it is the minimum time within which a project can be completed. Sometimes it is a little bit confusing to look at it this way, but it is the longest path, in the sense the path cannot be shortened, because the events are sequenced and there is no float in it, there is no slack in it, and then they will complete, and this is the critical path. That is why that gives you the minimum time within which the project can be completed. But for doing this critical path analysis, we have to start learning to identify what are the earliest occurrence time of an event, when it can first happen. And then similarly, we also have to identify what is the latest occurrence time that is there. How do we define these two terms? The earliest possible time to reach an event is that all the activities prior to that event should be completed, then only that we reach that point. The latest one is the latest possible time to reach that event without affecting the overall project duration. That means there may be some delay or something, but it will not affect the overall path if you are able to finish this task by the latest occurrence time that needs to be done. Identifying these two times, the earliest occurrence time of an event and the latest occurrence of time, is necessary for us to understand the critical path method. Once we have identified these two, then we attempt to discover the critical path by either going by a forward pass or by going through a backward pass. And what is the forward pass? When we start with a starting event and then keep allocating the earliest occurrence times in the order of the increasing number of events as we go, then that is called as a kind of a forward pass. But if you are looking at it from a backward pass, what do we do with this? Then we start with the ending of an event and then keep allocating the latest occurrence time in order of decreasing the number of events. So, that is why we reach backward and then we reach the start time. And what is the advantage of these doing these two? We will see when we try to understand the slacks and the floats. And the project duration is the minimum time to complete a project. This will be understood by the critical path. And then if the events are delayed which are on the critical path, then they will delay the project duration. So, sometimes it is possible to address the delays in the project by deploying some of the resources of men and material and equipment to address these events which are lagging behind and then which are already lead. So, for this understanding we need to develop some ability to identify the slack and floats that are available. How do we look at a slack? Slack is the maximum delay possible for an event without affecting the overall duration. So, this is simply the difference between the latest occurrence time and the earliest occurrence time. So, that is how the slack will give us. So, even if this delay occurs, it will not affect the overall project duration. The float is simply understood differently. The float is related to the activities, and then the maximum delay possible for any activity is called as a total float without causing any delay in the precedence or succeeding activities. It will not affect the other activities, but that is the maximum delay possible for that. The free float, it is maximum delay possible for activities which will not affect the float of the successor activities. That means even if this activity is getting delayed a little, it will not affect the activities which follow it. So then that is called the free float. Then we have the notion of this independent float, which is the maximum delay possible for any activity which used floats of preceding activities and will not affect the floats of the succeeding activities. That means it is independent, it is not affecting either the preceding or the succeeding events. So far in this session, we have tried to understand the use of networks in project control, and then how we can do it is by developing these network diagrams and also understanding the critical path method, and then identifying what is the critical path, what are the activities which can be delayed, which needs to be finished, etc. And for this development of this understanding, you can make use of the materials supplied to you by Manage, or visit the websites, or look at some books and other things which are developed on understanding the critical path method, especially those which are used for project network analysis. Thank you very much, and then all the best to you.